This video is going to focus on using open source photometry analysis programs, specifically pMAT and GuPPY. Parts 1 and 2 will focus on pMAT, both formatting CSV data files and then using data in pMAT. And then parts 3 and 4 will do the same for GuPPY. If you want to see a comparison of the outputs between the two programs, you can read about this in the accompanying written post. So let's start with part 1, formatting a CSV file for use in pMAT. So here on the left, I have a Plexon exported CSV file example, and on the right, I have the formatted CSV file for use in pMAT. Let me point out some of the differences and similarities. In the Plexon exported CSV file, the first column is going to be frame, followed by timestamps, and then multiple columns of data. Each column of data is going to have a wavelength for the LED. So here we see 465, 410, and 560. It's also going to have an F1, F2, F3, or F4, depending on which fiber the data is from. There are also 3 different types of data. Here I am just showing the raw F, which are the raw fluorescent values. There's also an F0, which is a moving baseline, and R0, which is baseline corrected. Because pMAT and GuPPY both do the calculations starting with a baseline correction, you want to start with the raw fluorescent values. So conversion from the Plexon exported CSV data file to the pMAT formatted CSV file is simply a matter of deleting the columns that you no longer need. So you no longer need the frame column, and you can only have one signal column and one control column in the pMAT formatted file. So if you want to do an additional analysis with 560 and then use the controls 410, you would need to have a separate file for that. The columns must be in order: timestamps, signal, control. So if you're doing 560, it would be timestamps, 560 signal, 410 signal. The headers can be whatever you want as long as they're there, but pMAT is not concerned about what you have the columns labeled as, simply that they're in the order of timestamps, signal, control. The second step is to format the behavioral output files. So these are any events, TTL pulses, etc. Exported directly from Plexon, you'll see column A is frame number, B is timestamp, and then C is either a 0 or a 1. A 1 indicates a TTL pulse or event was detected during that timestamp / time frame. If you have multiple different events, you will have multiple columns, one column for each event. Here I'm just showing one event. To note, in the examples I'm going to be showing you, the TTL pulses that were programmed are 0.1 second long. With data collected at 30 Hertz, that means there's 4 data points per TTL pulse. However, as you can see in this example, there are more than 4 consecutive data points associated with this event. So that's because the TTL pulse start and stop are not always exactly aligned with the start of the frame and the end of the frame. So this leads to a little bit of TTL length jitter. And I'm pointing this out especially because pMAT, it wants not only the event name, but the onset timestamp and the offset timestamp for each occurrence of the event. So here in my example, I have shown just a sample of these data. So if you have multiple events, you can actually put them in the same file to be used in pMAT. It would just have different event names. The onset timestamp would be the first timestamp where an event is detected for that TTL pulse. An offset would be the last timestamp. So to note, currently pMAT does not actually use the offset timestamp in its calculations. So you could just put ones here or onset plus 0.1. However, in future versions, they have said that they are going to include a feature to analyze events with varying lengths, in which case you would need both the onset and the offset. So it's worth it to do the little bit of extra work to find that offset point so that in future versions of pMAT you don't run into any errors. So while formatting the fluorescent data are fairly straightforward, you're just deleting a few columns, finding these onset and offset points in the behavioral or TTL event file is a little bit more tricky. So I'm going to show you how to do it manually, and then I'm also going to show you sort of a cheat sheet that Plexon has created to help you do this. So here I have opened a exported TTL event file directly from Plexon's multi-wavelength for photometry system. Here you can see again, the first column is frame number, B is the timestamps, and C is that one event with zeros or ones. So immediately I'm going to save this, and I'm just going to save it as manual formatting, just so that I can edit this file without modifying the original in case I need to go back to it for whatever reason. When you're finding these timestamps of where the event occurs, the first thing you will do to find them manually is select all three columns, and then you will use the sort feature in Excel. So what we're going to tell Excel to do is sort by the value in the air puff column. And then we're going to tell it to sort it from largest to smallest, because we want to know which rows have the number 1 in the air puff column, indicating that there's that TTL event. So as you can see, it finds where there's 1 in the air puff column and then puts that row towards the top. And then it does this in a sequential way, so that the next one it encounters, the next one, the next one, the next one. So we can then make a little table off to the side with event, onset, and offset. So in pMAT, these headers, again, don't have to be perfect as long as they are in the correct order. However, I do like to use the terms event, onset, and offset because I think they're very descriptive. And so it's kind of as a placeholder, I'm going to put air puff under the event name, and then very simply, I'm just going to go and copy, paste the first timestamp, and then find the very last timestamp in that consecutive event occurrence. So here you can see the last event occurs at frame 7797, which is this corresponding timestamp. And then I'm actually going to color that a little bit of a different gray to know that I've already done it. And then I'll move on to the next one. And you can see there, I got a little bit lost, which is very easy to do when you're doing this kind of thing manually. So I know I only have about 13 air puff events in this particular file, and it will still take me 3 or 4 minutes to actually go through, find the start and stop TTL. So what we've done is created a cheat sheet file. This file will have 3 sheets. The first is the rules, which I'm going to be talking about as we go through this. Essentially, you're going to just paste your data straight from the raw file from Plexon into this sheet where it says paste data here, and then it's going to reformat this and create the pMAT event, onset, offset table, which then you can then copy and paste into a new CSV file. So I'm going to open the original event data file, not this one that we've sorted, although you could use the sorted data if you wanted. It does not make a difference, but I want to show you how it works with the original data. So I'm going to select the first row, and then I like to use the keyboard controls and hold Control, Shift, and then down. And so this will select all the rows with consecutive data. So I'll just copy that, go back to our little cheat sheet. Because I copied the headers, I'm going to paste in A2. And so this, if you paste the headers, it will change these event names, which will then change on the reformatted page. So because you have thousands and thousands of rows of data, this is actually going to take a minute to calculate because it's doing everything I showed you manually, sorting, finding onset, offset, putting in a new table, kind of off screen. So give this a second to do those calculations. Go get a snack and then come back. By video magic, we have skipped to the end of the calculations, and now we can go to the reformatted tab, and now we see our newly formatted event table. You can do up to 6 events in this file, and they will all populate different tables. So then we can create a new blank workbook. We will copy that newly formatted table, and this is very important. When we paste into the new file, use paste values. Because the cheat sheet from Plexon uses formulas to find and correctly populate these tables, you want to just paste the values, not those formulas. That's why you have to use paste values. Otherwise, you're not going to get the same results. You're not going to get the correct numbers in your new workbook. Okay, so I've pasted values, and then I can do a save as. So I have saved all my files on my user folder on the C drive under a photometry folder. Here's session 11, and then I have created 2 folders, GuPPY formatted, pMAT formatted. So we're going to go into pMAT formatted. So we need to make sure that this is a comma delineated CSV file. And you can see I've already done this, so I'm actually just going to resave over the behavioral file that I've previously done. Okay, so now we have our behavioral file saved, and we've already formatted our fluorescent data file. So the next step is to then actually use these data